Okay. Hello everyone, I hope you had a good day on the water. It was good, everyone was happy about his day, about his timing, qualification were okay? Not an issue? Some? No damage? Okay. We will not have damage tonight, I hope for. Let's go on the second day of the Tech Talks. As you know, you have all the jury here to see all your evolution. Basically, the Tech Talks are the opportunity for you to share with your other team the innovation, the spirit, but also the spread about your value in order to foster people around your project and giving the chance that this jury can vote to your team in order to be the ones that won the awards on the Tech Talk prize, but also on the New Generation prize. And the New Generation prize this year will allow you to be introduced to some potential investors to create your company, and that team will be able to invest in your company. I was not sure that you were aware of that yesterday, so that's why I really want to highlight it today, because the opportunity of these Tech Talks is not only giving a chance to the young student of your team coming on the next year to be better, but it's also an opportunity to you to be well connected to this world of industry and to the world of the investors that really want to have an impact investment. And this is exactly why you have the jury and why these Tech Talks are so important. So, as you know, the regulation is a bit more strict this year. We have this light here. So just also to explain a bit more details, because I had some question yesterday afternoon about the color. In the first minute, the light is green. On the last minute, the light is orange. After 5 minutes, the light is red. When the light red starts to check, is 1 minute pass, meaning that you have -1 point on your Tech Talks presentation. When the light red is stopped, you are obliged to stop the presentation. Each minute over the limit time, it's minus points on your presentation. So I guess that was not well explained yesterday night. I apologize for that. We will try as a jury to be a bit kind with them, but we will oblige to respect the rules this day. So good luck to all of you, and really looking forward to see good innovation, and it's basically mainly sharing that you want to go around these presentations. Do you have some question? Is it crystal clear to anyone? Great, so let's start. Can we please have on stage Unigi Electra?
Prova. For the slides? No, I know, but... Okay. Okay. Hi, everyone. I'm Manuel De Luca, one of the head designers of the Unigi Electra. We compete in the energy class for the first year. So we live in Genova, and given our city's strong vocation and tradition for the sea, we thought it was time to get involved, to prove ourselves in an international competition. And the first question we asked ourselves was, what is the point of the competition if we only assemble off-the-shelf components? And so we tried to make something that was ours, was personal. About the innovation, first thing, we have built and designed a tailored 3D printed propeller that was optimized for the matching with our powertrain, and also a self-made shaft line, for sure with the help of our partner San Lorenzo. About the eco-conception, we have decided that all of the University of Genova electricity comes from renewable sources, so we have low impact from that point of view. We have reused a lot of stuff, but we'll get there, like the aerodynamic cockpit, also courtesy of the San Lorenzo shipyard. This is just the flow of our design. Propulsion energy, plan A. Why plan A? Because we have a plan B, luckily, but we'll get there later. This plan involves just the traditional components, so a battery pack, namely 5 of them, with a nominal capacity of 8.2, made in Italy electric motor with a rated power of 9 kilowatt, and then an inverter. The plan A is the Earth of our innovation. We start from the point that commercial propeller cannot properly fit with any boat. They can fit with the typical boat that employs the propeller, but not properly. So since we have some strong know-how in hydrodynamics, we decided to design and build a tailored fixed pitch propeller, and after many iterations of the main parameters, we were able to reach an open water efficiency of the propeller of 80%. That is really high. And then the tailor-made shaft line. We designed all of the shaft line. Was really challenging. Basically, is an L shaft line with a 101 conic couple and self-made joints to pair the main components of the shaft line. And then the plan B. Why plan B? Because we knew about the risks of building such tailored components, and so we had the idea of having a reliable backup solution that involves the same amount of batteries but an outboard electric motor. That is the Golden Motor EZX20. About this is the classical chain of efficiency, starting from the efficiency of the motor down to the efficiency of the propeller, and then the efficiency of the hulls. So the weak link of this chain is for sure the efficiency of the propeller. And so we decided to work a lot on that, because improving the lowest efficiency can bring up the overall efficiency. This is just some details of the communication system. About the materials and the life cycle assessment, we reused a lot of stuff, as you can see, aluminum, wood from the university reserves, and we reused the San Lorenzo cockpit, as you can see in the image. About the LCA, we assumed that the production phase was the most impacting. In fact, it is. We know we have impacted a lot, but we think we will reuse a lot of stuff in the next year competition. So we really think that reusing and recycling is one of the key for sustainability. Then we had some tests. I will listen to that because I have no time. And then the problems. Well, it is our first participation, so we had lack of time, lack of organization. And lack of time means we had no time to properly fix our mistakes and our failures. 2 batteries out of 5 broke down. The shaft line design and production took longer than expected. And then most importantly, you remember that propeller that had this very high efficiency. Well, during the first sea test, it literally crumbled due to incorrect dimension, we think. So we rapidly found another propeller that, during a short-sighted slam star, damaged itself and also damaged the hulls, causing a flooding. So we were really unlucky, but anyway, we are here to compete. I'd like to thank all the members of my team, and thank you.
Congratulations, very nice presentation, especially for a first tech talk and a first presentation. Do we have some question on the stage for the gentleman? Don't you want to?
I have 2 questions about the propeller. Why don't consider control rotative propeller? And what is the main advantage of your conception?
Okay. Why not control rotating propeller? Because it's our first participation, so we went with something more plain. And then, what do you mean with our? What?
The main point, the main advantage
of our solution,
yes,
with respect to the control rotating one.
Of your solution, yes.
Okay. So via iterating the main parameters, as the pitch on diameter ratio, the ratio between the expanded area and the area of the blade, we were able to find the correct set of parameters. Were able to bring the open water efficiency so high. So that's what we have done.
Good. Do we have another question? I have a question, maybe that can maybe use most of the team. So we understand, because that was your first participation, you made some mistake, issue, like that. The thing is, out of the tech talks, how do you capitalize those mistakes? How do you capitalize why you have these chosen? How you organize basically the IP and the knowledge you develop around this project? I guess it's something very important for all of the team to know that when you have some issue, it's important to explain to the team, especially for the students that come on the next year, why this decision was taken. And this is also something very important in all the companies. If we want to protect the IP of the companies, especially with new generation arriving, that we really have to organize why we have taken this decision. Do you have an idea? Maybe not, it's okay, but that's something that I really want to highlight because you was very open to share that you had some issue, and I guess that's important to share that for the next generation.
Okay, wait.
I'm not completely sure I get the question. I try to reply and then you say, the point is what we learned from our mistake and why we decided to share in this way.
And how you are explained to the next ones that will have, I don't know, maybe you will pass the exam, you will be hired and get out of the university. A new student will arrive and say, okay, that's a former design, but why this is his design? How I can understood that that was the correct decision?
Well, it was not the correct decision because it broke. Is that what we discovered? Yeah, well, regarding our propeller, probably there has been a not probably a misdesign, but a miscommunication with the production company in order to align on the resistance of the material and so on, and if it can hold the stress. And what we can learn, probably the most important lesson, I think, is that such a project from scratch requires more than 6 months to, to obtain a viable solution.
Okay. Jerry?
Can you elaborate, because 80% look quite high in terms of efficiency. Can you elaborate how you measured the efficiency?
Yes, sir. We didn't measure it. It was CFD calculations.
So it was not theoretical?
It was theoretical, yeah.
Okay,
Yeah.
now I understand.
We didn't have time to measure it because it broke.
Normally there is a gap between theory and practice, but...
I guess it's okay. Thank you so much, gentlemen. Sorry, we have another one.
One question. Thank you. So the question is, how did you, why did you decide to go through the shaft line instead of going with a commercial one? Like, what are the benefits of designing your own shaft line?
As I said, what is the point of the competition if we only assemble off-the-shelf components? That's what we asked ourselves. So for sure, buying some components and assemble them, it's easier, but it's less challenging. So we decided to design all. Then we regret it, but...
Okay, thank you.
No, we don't regret completely. We have been unlucky, but if it was working, for sure it was better than an off-the-shelf solution. This is what we have to say, obviously.
No, but congratulations, and that's exactly why we're organizing the Tech Talks, and that's why you should have a look at the one that was in the previous year, but that's for the next year. Thank you. So, gentlemen and ladies and gentlemen, could you please now have on the stage C. Sakti, coming from India.
A very good evening to all present here. We are Team C Shakti. First, I wanted to deliver my sincere thanks to the honorable juries and the YZM organization and other teams for having your presence in this wonderful evening. So I'm Hemalata from Team C Shakti, lead in operations and management, and with me, Anjana Prasad, who is the lead in propulsion system. So we are here to present the journey of a young Indian team all the way from a rich cultural country and also with rich maritime history, India and a state called Tamil Nadu feels immense pleasure participating in this prestigious Monaco Energy Board Challenge, because this is actually not an event for us, but as an eye-opener, and thus we are in our second season this year. So in this competition, we are not just participants, but also a beacons for a sustainable future. And thus Team C Shakti, with a brilliant and smart 10 engineering sophomores from Kumaraguru College of Technology, Coimbatore, but with one vision of abating the carbon dioxide emission to the environment through our innovation in engineering. So this is our team, 10 engineers from diverse domains.
Well, thank you, Hemalata. All right. So, as already pointed out by Hemalata, we come from a country with a rich maritime history. Hence, we proudly call our boat the Yali, Y-A-L-I. So, looking at the features of our boat, Yali, it is powered by a 48-volt, 8.4 kilowatt-hour LFP battery and a 2 kilowatt hydrogen fuel cell. Thanks to Monaco Energy Board Challenge and, Monaco, because this made our catamaran, India's first hydrogen-powered catamaran. And about the secondary source of energy, we are using a set of solar panels of 100 watts. And about the cockpit, it is a monocoque. It is monocoque in structure, and it is completely made out of carbon fiber. And the topology of the cockpit is inspired from that of the tiger shark. And about the propulsion system, so this time we had made our own propulsion system, an azimuth type propulsion system, powered by a 6 kilowatt BLDC motor. Yep. So next up we have the project budget. So to build the boat, it costed us around 23,000 euros, majority of which was used in the energy systems. And looking at the, the flow of our project, we started with the concept sketch and the design of our boat. And as soon as the results were out, we started procuring the components for the, procuring the components and started the fabrication process. And then in the month of May, we were done with the assembly and all that, and the fabrication process, and we had gone for the testing in our home waters. And yep. Looking at the features of the cockpit, so the entire cockpit is monocoque in structure and is completely made out of carbon fiber. And the entire cockpit weighs under 25 kgs. And one innovative feature that we have for the cockpit is the presence of canards. Canards are winglet, wing-like structures that you can find on sports cars and, and aircrafts. So we have integrated a similar structure in our cockpit, in the nose cone of our cockpit. Yeah, this is one innovative feature that we have incorporated for increased, aerodynamic performance and aerodynamic balance in the front. And energy on board. So we have 3 sources of energy on board. One is 8.4 kilowatt or 48 volt 8.4 kilowatt LFP battery, which makes up to 67% of the total energy on board. And then we have a 2 kilowatt hydrogen fuel cell, which makes up to 32% of the energy on board, total energy on board. And then we have used a set of solar panels, which makes up to 1% of the total energy that we have on the boat. And looking at the features of the propulsion system, so the entire propulsion system is powered by a 6 kilowatt BLDC motor. And we have used a 3-bladed anti-cavitating high-pitch propeller. So this propeller has a pitch as high as that of a 17-inch. And we have also incorporated additive manufacturing technologies for, to print the casing of the motor and to print the casing of the lower unit. And yep.
So talking about the life cycle assessment, I know how important it's for a presentation. So it's just a model to quantify the environmental impact, right? So in that row, I have majorly focused on 3 parts: the hull, the cockpit, and the internal components like battery, hydrogen fuel cell, and the propulsion system. Talking about the hull, as every team is making, we have manufactured last year using FRP, and we use it for the testing purposes in our home waters. So as a result, we reduce about 514.24 kgs of carbon dioxide is being emitted to the environment. So that is being eliminated by using the same hull. About coming to the cockpit, as she said, our Yali 2.0 is actually a carbon fiber monocoque structure, and it is lighter in weight, stronger in strength, and highly efficient. There is a research says that 90% of the recycled mother carbon fiber. From that, a child carbon fiber is recycled, which possess 70% purity content in it. And thus, our cockpit is highly efficient, as we can assure it. And about the internal components, battery, once it is bought, it can be used for many other applications. And hydrogen fuel cell, it is the only hydrogen conceptual product we have designed in our institution, like it's the first project we have developed. So that goes under our research and development and can be used for the study purposes for the students too. And about the propulsion system, as we designed the custom design high-speed electric propulsion system is being commercialized. Sorry, I just put my remote in my pocket. Yeah. Sorry. Excuse me. Okay.
Okay, we are already running out of time. So, like we did, incorporated some ecological features to the boat. So we have completely manufactured the seat out of natural fibers out of jute and hemp, and it had a massive maximum tensile strength of 148 megapascals, and the cockpit weighed under 2.5 kgs. And the innovative, no.
It's okay, ladies, I'm sorry, but I was supposed to check the belt, but the next one will have that. Thank you so much for the presentation. Do we have some questions on the stage? Julie?
Yes, for 1% power, did it worth to add the solar panels?
Sorry, can you come again?
For only 1% electricity power, did it worth to add solar panels?
Actually, complying with the rules of the energy boat challenge, we actually had to go with a secondary source of energy. But I think the battery and the hydrogen was actually sufficient for us to, comply with the challenge. So yeah, the 1% of this is actually a minor part of the whole energy on board. But yeah, did I answer your question? No. Okay.
Other question? I do have one question. Sorry, I'm very oriented Tech Talks. Did you had a look to the previous year to all the documents that was shared by the Yacht Club of Monaco in order to prepare your boat? How was it useful? Do you had some good ideas coming out of it, or do you had some maybe orientation that you should have not taken without this orientation?
Are you asking the difference between the Tech Talk presentation that we had last year and?
No. So you decided to use a battery plus hydrogen.
Yes. Yep.
Was it your own decision, or was it after all the experience you had with the other team?
Well, exactly. Like, I don't think we would have made these big decisions without coming to this challenge, because Monaco and the challenge was an eye-opener and the turning point of our lives for most of the participants in our team. So it is after coming to this challenge and after coming to this country that we had decided to go with hydrogen fuel cell this time. So yeah, the country and the challenge played a big role in our decision with going with the hydrogen fuel cells. I hope I answered your question.
Yes, perfect. Other? Thank you so much.
Thank you.
Can we please have on stage AGH? So a team representing on one guy.
Good afternoon. My name is Paweł Garas. I'm a mechanical team leader at AGH Solar Boat. I'm honored to present you our tech talk this year, our innovations from that season. We are a solar class team, which participate in Monaco, and we are representing Poland. We are from Krakow, from AGH, which is one of the best technical universities in Poland, and we are here for 6th time, so we are happy to participate again. We've starting in Monaco with Celka, which is our second boat, second 6-meter boat. Our first boat was Baśka, which is her predecessor, and which was our biggest inspiration to build Celka, to improve the parts that we thought will be better and will be more competitive. Celka is 6 meters long, 1.65 meter wide, and also her top speed is 35 kilometers per hour. Our propulsion system was built with thought to be as more universal as possible, to develop it through years. It was built meant to be using 2 BLDC motors, which can be used simultaneously. Also, we've done some FEM simulations to calculate the stresses with nacelle. As you can see on the render, we have aluminum nacelle and carbon fibered strut. The hull was made with goal to be as lightweight and as strong as possible. It's made of carbon fiber and honeycomb, aramid honeycomb inside. And we are really happy about the result because the hull and deck weighs just above 40 kilograms, which we, as I said, really happy about the result. Also, we've done FIA simulations to calculate the stresses and places where we need more carbon fiber layers. The cost of Celka was around 50,000 euros, and to come here to Monaco from Poland, we estimated the cost of 2,000 euros. We built Celka 2 years ago, in May 2021. Our main innovation that season is a new foiling system, a new foil steering system. The goal was to make this for that Monaco to foil on the sea and to be as strong and lightweight as possible. The impact of innovation. We've calculated that on foiling, we have around 2 times less energy consumption than non-foiling boat. The struts are made entirely of carbon fiber. In our workshop, we've done also CNC machined molds to layer them. And we calculated using, again, CFD and FIA simulations, them to be as lightweight and as small as possible. Our new hydrofoils for the new steering system are made of carbon fiber and foam inside, so they are really lightweight. They can even float on the water. And also we calculated the tips, the endings, to be as efficient as possible. As you can see on the CFD contour, the contour represents the kinetic energy losses. We are really trying to be as responsible for the environment as we can. As you can see on the graph, the building of Celka costed around 3.6 kilograms of carbon dioxide emissions. We calculate that obviously after we built Celka, because it's that year calculation. And surely we will, when we build next boat, we will calculate that to be as low as possible. As I said, we really care about environment as we can, and to make that possible, we have cooling water from engine from the outside sea. So with our pumps, we get it with our pumps and then take it back to the sea. So there aren't any oils, aren't any other material needed. Also, we've built our custom battery accumulator, which is better, more efficient than the ones we can buy. Also, we're doing our own PV panels, which are more efficient and especially more lightweight than the one we can buy. So the Selka isn't that big, that heavy. Also, they are really efficient. We buy cells that are 21.4% efficient. And thank you. I can ask you.
Thank you. Do we have some question? They're not that curious, huh? Aye.
What is the difference between your batteries and the standard batteries?
You mean in accumulator? Yes. The battery, I'm a mechanical team leader, so I'm not really that entirely in that topic. However, as I know, they are more efficient and we can cool them with air easier than the one we can buy.
Thank you. Do we have another question?
Which were the biggest issue putting a foil and combining it with the motor? So the foil in the motor shaft, what were the most critical problems you needed to solve to integrate the two components?
Okay, if I understand you correctly, you mean the front wings as I presented, new steering system. The biggest problem was definitely stresses, because you need to calculate the right momentum on the connector between servo mechanism and wing. However, in my opinion, the biggest problem is the dimensioning between carbon fibered part and the aluminum part. Because there aren't any dimensioning, any strict dimensioning, so we always needed to add some material or cut some material. So in my opinion, it was the biggest problem, not entirely the stresses, because there aren't that much, in my opinion.
I guess if I may go a bit deeper in the question. Also, one of the questions in this competition is, where can we put the thrust compared to the foils in order to have a very efficient thrust and an efficient foiling effect, in order to avoid, the vibration from the shaft going closer to the foil? Or do you want to use the speed of the thrust in order to lift even more the boat? I know you are a mechanical engineer, but
I'm not sure I understand you correctly. We currently, when we foiled the first time that season in June, so roughly a month ago, it was on plain water, stable water, and we had two foils, one bigger and one smaller in size, and we can float just by speed on keeping on wing on 0 degree. And it's just pure physics. You can float just by your speed. However, the biggest problem is then turning, especially tight corners. With bigger wing, you can do it better. You can regulate with software that turns better. So we've used bigger wing to foil. I hope I answered you correctly.
yeah.
Yeah, I had a question. Is the foils, I believe, they're actuated by the pilot, right? Or is that?
You mean how we steer foils?
Yeah, how do you foil?
Yeah, currently it's a bit rough. I mean, it's not that elegant as example yours, because we've done it by joystick, which is just done by pilot, and steering help done by software. So it's not entirely software based, because we didn't just have time that year to done it entirely software. We hope that in half a year we will done a mathematical model in MATLAB, probably, and then done entirely software regulation of the steering system, of the foiling steering system.
And do you need much training, or is it just?
Yeah, we've done. I think pilot needed 2 trainings for 4 hours on the water, and Then it was just clicked, and he knew entirely how to foil. Really.
That's cool.
Thank you. And just something, when you are speaking all this, let's say, community, don't speak about having oils inside the boat. Huh? Otherwise, no, it's perfect. Thank you so much.
Thank you.
And congratulations for coming alone. Could we please have on stage Technico Solar Boat Energy, please?
Is it on? Sorry.
Yeah.
Hello everyone, my name is Mafalda Abreu and I am the team leader for Technic Solar Boat, and today I have alongside me Guilherme Carvalho from the Hydrogen Systems Department. Technic Solar Boat is a university team from Instituto Superior Técnico in Portugal. We were founded in 2015 and right now we are a team of 64 members from different engineering fields. We right now count with 5 prototypes in our portfolio. Approximately 4 years ago, hydrogen became a part of our stories alongside with São Miguel 01, which is our first hydrogen-powered prototype. This boat has a 5 kilowatt PEM fuel cell and it is exclusively powered by hydrogen. Well, in the past we have had some issues regarding condensation and cell drying. So right now we have a humidifier in our systems and some self-made solutions that we have developed in our R&D department. And besides that, we have had some issues regarding our box. Some of you had already called it a magic box because we're always looking into it. And we decided to change it a little bit and make the electronics a little bit more accessible and to separate it from the hydrogen systems.
Okay, so behind me, as you can see, we have here all our fuel cell systems, but I want to bring your focus to a specific part, the recirculation hydrogen system. Last year we bring to you our homemade water purge that purges the water from the recirculated hydrogen. But we knew that we could improve it, we knew that we could better, so we did. I'm very glad to present you our innovation, the Venturi injector. The first thing that you may be asking is, what is a Venturi injector? Okay, so a Venturi injector is just like a recirculation pump, but with 3 major benefits. First, it doesn't have any mechanical parts, it doesn't vibrate, and it doesn't use any type of energy. You may be thinking, okay, this looks like magic, but it's just physics and the Venturi principle. The hydrogen comes in the primary inlet from the tanks, and then it gets accelerated in the nozzle. It creates a differential pressure that sucks the hydrogen from the recirculation inlet, goes all of it to the outlet, into the fuel cell inlet, and then this cycle repeats all over again. Okay, but with a project like this, it took us a very long time and very problems. We faced 2 major problems: backflow and assembly. Backflow is just when the hydrogen from the inlet goes into the recirculation inlet, and this can damage the fuel cell and broke our systems. We tried to solve this with a lot of CFDs and a lot of research to come up with a perfect size Venturi injector for our system and for our fuel cell. The assembly part, we tried to 3D print it in just one piece in resin, so it's much more easier to assemble. It's just to connect the tubes and we are done. Here you also can see a time lapse about all our prototypes. As I said to you, we did a lot of CFDs and then we tried experimentally. I'm very glad to announce that we obtained only 50% error between the experimental data and the theoretical data, that this don't look like much, but imagine this. All the other papers and all the other research that we found will obtain something like 60 to 70% error, so 50% I would say that it's a very good result.
Well, a little bit about our conception price, because our main goal with this boat was to have it as ecological as it could be. So what's best to evaluate that than to use the basic 3R rule. So after some research, we opted for using flax fiber instead of carbon fiber. We used PET core instead of PVC core, and we also used a bio-based resin. So with the choice of these materials, we could do a check in the first 2 R's, the reduce and the recycle. And lastly, we reused some molds from a formerly student team from our university. So this way we save the resources that we would use in this process. A little look into our LCAs. I will try to sum it up. But regarding our potential global warming, we had a value for the total emissions of 2,060 kilograms of carbon dioxide equivalent. And just so that you have an idea of what this represents, it would be the same as driving a regular passenger's car for 8,100 kilometers. And besides that, we also have the energy consumption during the production of these materials and during the lamination. And we observed that 13% from it were from renewable sources, and we were actually expecting a higher value. And regarding the emissions that we had, because we found it interesting to compare the boat that we made to what it would have been if we had used the same materials that we used in our solo class vessel. And we observed that with the choices that we made, we were able to reduce the emissions related to the lamination process in 30.5%. And this is mainly due to opting for flax fiber instead of carbon fiber, because we have observed in the graphics that flax fiber absorbs the carbon dioxide while it is growing, so it does change a lot the results. We also made a comparison between the hydrogen and the fossil fuel or the diesel, and of course that we observed that it is a lot better. Well, I would just like to say that the biggest lesson that we've had here is that all of these projects are a reiteration process. So I would like to give you some kind of teaser to the second prototype hydrogen power that we will have, because we will probably have to rethink again, have a lot of overthinking in what we have achieved so far. I would just like to say that we are an open source project, so this means that you can go to our website and you can download all of the work that we have developed so far, because one of the main issues that we have had is to have sharing information not only on this class, but only on the OpenSea class boat that we are building right now and that will have hydrogen. We would really like to see, especially the hydrogen industry, more open and more available for helping. Thank you.
Congratulations. Do we have questions?
How is the response time of increasing the throttle? Does the hydrogen accelerate?
Well, it is not the same as our solar class vessel, but I wouldn't say it is bad. We do need to turn the boats on and wait just a little bit, so it's not as responsive that way. But on accelerating, I would say that it depends more on what you do with your throttle than with the hydrogen, as long as you have the boats turned on.
Do we have another question?
Thank you very much for your presentation. Just one question. You said you use flax fibers and you used search on it. Why didn't you use basalt fibers? Was it for the weight?
Well, actually, we were pretty excited with the flax fiber, and also the basalt fiber was really expensive. Right now, we are thinking of using it because we got a new sponsor, but at that time, which was in 2020, if I am not mistaken, we just went for the less expensive solution, since we have right now 4 boats happening at the same time, and we don't have that financial resources. But yeah.
Thank you very much.
Other question? Julie? Yeah.
Got the microphone. Just a quick one. What is your plan to recycle flax fiber composite?
What is what? Sorry?
How do you recycle flax fiber composite? Do you have a plan for that?
Yeah, the cutoffs. You can recycle only the cutoffs, and the end of life of our boats, we usually don't put them aside or throw it in the trash. So we are always using them for some testing or even to expose in our university. And that is the reason why we didn't consider the end of life, because so far, since we were founded in 2015, we don't have an end of life, because we are also taking some good care of our boats and trying to learn and to share our message with it.
My question is relative to the injector with the Venturi effect to recuperate on the pressure. Can you elaborate the reason? Because obviously there are no moving parts, but there are also some disadvantage with that type of system. So what was your reasoning to go instead of using a conventional compressor or pump?
The thing, I think that the reason that we started with the Venturi ejector is the main reason was that it doesn't use any type of energy. And I think in this type of competition and in this type of engineering, we want to not only to try to stop using fossil fuels and things like that and start using renewable energy, but also to start trying to save any type of energy that we can. Obviously, we face some disadvantages, as I said to you, but the thing is, I think that all the advantages that we have compensated the trouble and the work that we needed to do to obtain the results that we obtained.
I do have a question, because we see you since many years now, Technical Sabot, so you just come with a fantastic team with new good ideas, open source. So what's the next plan? So, you know, in our notation as a jury, we want to see, okay, how you can foster the industry. What's your objective after Technical Solar Boat?
Well, I think that probably 90% of the team members wish that we would form some kind of company to do exactly the same thing that we're doing right now. And I believe that everyone here seated would like to do that. I do start to see that what we gain the most from being in this type of team is that we find people who are similar to us. Not everyone in the team is going to be a friend or your teammate for life, but there are some people that are valuable in their work. So what I'm starting to see is that we start gathering together and we're starting startups and we're just trying to get into the energy world and the technology world. And we are slowly kind of making an impact after being on the project. I don't believe the Technical Solar Boat is going to become a company because of what it has and what the impact that it has in the university. But I do believe that the people that go out from the Technical Solar Boat and the other teams as well are going to have some sort of great impact in the industry.
Thank you so much. Could you please have on stage Physis PEB?
Good afternoon. Yes. Prova? Okay. Good afternoon. My name is Alessio. We are Physis Polymi Energy Boat. We come from Politecnico di Milano, and we are a team based on about 90 students. And this is our second participation, but as you know, we are not racing in the water. Indeed, this is our prototype, but due to safety concerns about the electrical system coupling hydrogen with battery, together with our university, we decided to take a step back. Anyway, to update and optimize our project, we spent more or less 23,000 euros, not mentioning the 8,000 euros for transport to carry out tests and to come here to Monaco. Then this was our timeline, starting with team formation, and then through design and testing phase, we arrived to a safety check that are still in progress on our final configuration.
Okay, so firstly, our energy system is a hybrid system composed of a 4 kilowatt-hours lithium-ion battery, coupled to a 3 kilowatt PEM open cathode fuel cell. We are currently developing a recirculation system, but it's not available yet. And our hydrogen is stored in 3 tanks at 200 bars of pressure located in the back of the boat. The boat mounts a 10 kilowatt electric motor, and the main focus of this year for the powertrain department was the design and optimization of the propellers. So the starting point of the design process were 4 considerations: needed thrust, the efficiency map of the motor, the available energy from the energy system, and the properties of the materials that we used. From there, with the aid of a software from our sponsor company Hydrocomp, we had as an output performance and structural analysis. And with an iterative process, we reached the best compromise for efficiency and safety factors. So this year, our team is competing for both of the prizes, Innovation Prize and Eco-Conception Prize, because we believe that sustainability and innovations are 2 concepts that, especially in this point in time, that cannot go without each other. So for the Innovation Prize, this year we present Intelligent Power Management System based on the Equivalent Consumption Minimization Strategy, or ECMS. This is a math-based strategy which optimizes the power split between the fuel cell and the battery by minimizing a function of 2 variables. The hydrogen consumption, so basically finding the best efficiency point for the fuel cell, and the derivative of the state of charge. From there, we use what is called sensor fusion, which means that we can evaluate if it is better to use data coming from sensors or data coming from the output of the calculation, with what is called an extended Kalman filter algorithm. This isn't a new strategy. Actually, it is already used in the automotive industry, especially in hybrid cars. But what we did is integrate it with the dynamics of hydrogen and the dynamics of the fuel cell. So basically, we combined the benefits of 2 existing technologies in order to obtain always more optimized solutions.
Okay, now let's talk about the Eco-Conception Prize. Materials are at the core of our project, and in collaboration with Lati, we developed 2 filaments for 3D printing with bio-based nylon from castor oil and recycled PETG matrices, and then they are reinforced with 10% of recycled and short carbon fiber. Then we use for 2 years basalt fiber, replacing carbon and glass fiber to do our last year cockpit, and we did a new approach with a forged basalt, with a short basalt fiber from GS4C and a 3D printed PLA mold. This is the result of our life cycle assessment of our vessel, and we didn't consider the impact of our cockpit because it has been made last year, and this is an LCA study of this season. But still, we calculated the impact of our cockpit, basalt fiber cockpit, by considering also 3 different scenarios, basalt, carbon, and flux fibers cockpit. So considering that the cockpit must have a specific mechanical strength, and it has been made by vacuum infusion, of course, the quantities of basalt, carbon, and flux fibers are different depending on the scenario. So finally, we deduct that basalt fiber has been the best environmental solution for our project. Thank you so much for the attention, and if you have any questions, we are here.
So, gentlemen, congratulations for your presentation, and also could you please share with all the team here, because I'm not sure that they do not know what happened to your boat. Could you explain why you do not participate today and maybe the next days?
Yes. So basically what happened this year is that we developed our system, our hybrid system, so hydrogen and battery combined. The fault, let's say, the little problem we had with our project is that we did not have enough hours of testing of the full system in water and in sea conditions. So what we agreed on the team and our university was that it was better for safety concerns not to race and develop all the security needed for next year's project. So we took a step back and we preferred to do like this because we felt more sure about it.
I really want that you applaud them for that because they are here, they made all this job, fantastic boat, but no racing. That was for all the effort. So now go on the question. I guess you are touching the point where when I designed the rules, I had these ideas about, okay, you can have a small battery for a fast race and also, let's say, other energy for the endurance race. So could you please explain me how you manage the optimum size in between the battery and the hydrogen storage?
Yes, so let's say we did a study of optimization at the beginning of the year, and we realized that even if, as the team before us said, hydrogen generation isn't that slow, for a race like the championship race, you really need the whole power available instantaneously. So what we did is that you calculated the least amount of, let's say, kilowatt hours storable in the battery in order to compete in, we hoped, every round of the championship. So from the first to the final. And because we wouldn't have time to recharge the battery between one race and another, so we said, okay, let's store all the energy for the whole championship race in the battery, and then the rest we filled with hydrogen tanks. So we're sure in every situation.
Do we have a question?
You said that you were doing a lot of work on improving the efficiency of your impeller. What was the efficiency, and is theoretically, or have you done any testing?
Okay, so the efficiency, as I said, we really tried with our software to find a compromise between the efficiency and the safety factor. In fact, we had to reiterate a lot of times, and especially thicken the beginning of the propeller because we had safety concerns. I do not actually know the exact value of the efficiency, but we were really, really satisfied with the results we had, and also the processing and the, let's say, surface finish of the propellers. We actually 3D printed our propellers, and the result turned out to be really satisfying. So I'm sorry I cannot provide an exact value, but we were really happy with the job.
Other question?
Hi. So first, congratulations about the presentation. And
Thank you.
yeah, my questions are more about the Simlink model. So the first question is like, your Simlink model, it's a virtual twin of the boat, as I understand. So did you do testing and calculated the error between the model and in the real life conditions? And the second question is about the optimization battery full cell split. Why and SEMS? Because it's a very demanding strategy at computational requiring. So in automotive, now they are using more rule-based or fuzzy logic because they are online strategies that request less computing power and are more easy to implement.
Okay, so regarding the first question, we did not compare it with real data. What we did is that we had other algorithms that were, let's say, unfeasible for real-time calculations, but that were really precise. So what we did is that we ran are the heavy algorithms, and it took the time that they needed to run. And we took that as a reference, and then we used our model to compare the results and see how different they were. Regarding the second question, yes, you are right. But what we did test when our model was ready. Actually, it's not 100% ready because it's a thesis project of one of our teammates, which is not completed. But what I can tell you is that it is enough. It's not fast, but it's not slow enough to allow real-time calculations. So it was a compromise between speed and preciseness.
Thank you. Do we have another question? Do you remember? In fact, I have one question for you, and after one question for the other team. The question for you is, because of what happened after the university safety issue, if you have to give an advice to the next generation arriving after you, what's this advice that you can share to all the team here?
Okay. So first advice, I guess, is it's better to take a step back rather than doing things if you're not sure, firstly. Second, from a more practical / organizational point of view, I would say really try to get to the race with a lot of hours of testing of your system, because you can do all the calculations that you want and try things, but if you don't apply things on your system as it would be in a race, and you don't go out at sea with waves and wind and water splashing, you won't know if the system works. So really try to push for weeks of testing before getting to a race. That's the main thing I would say.
Thank you. And now a question for all of you. Would you please allow those gentlemen that made 1 year of job on their boat coming here not be allowed to race on that boat, at least to sail on your boat? Some of you? After the race, huh? Yes, could you please put the hands up? So could you please give them the chance to drive one of your boats, because they work for the boat during 1 year. They just want to have the idea about what it is driving such a boat. Yes? 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 This is exactly what I want. Thanks to all of you, and thank you, gentlemen.
Thank you very much.
So could we please now have on stage Hydro Vinci from the energy class. So I took a bit more time with them because they did not race. So.
So, hello everyone. We are enjoyed to be here and to represent our school, which is the Léonard de Vinci University in Paris. This year, I could say that Hydro Vinci is the first participation to this race, and to do that, we have 13 members all the year to work on that. About our university, we are three schools. Yes, one about communication, one about management, and one about engineering, and we work together to build our boats. So,
So this year we made a lot of work on the 3D modeling of our boat. We searched to optimize the aerodynamism of the boat. We saw in that goal, we made simulation on fluid dynamics simulation to reduce the resistance of the boat to air and water. We also made a lot of work concerning electronics. We made our own embedded system to know the temperature of the sensitive components of the boat, like battery, MPPT. And we also added solar panels and such a new battery to our boat. And last but not least, we also choose to study the mass distribution of our boat. And we search the equilibrium point of our cockpit, and we balance the different mass that we had to to reduce the drag in water of the boat and go faster.
So when it comes to budget, we had a few problems that occurred. So we had 1,500 euros for transport, and for all the rest we had 3,500 euros. Also, we have some problems concerning. Also, concerning the staff, this year we didn't have enough members. Also, we had a member of our team who is responsible of the electronic part, who unfortunately went on an internship in April, and he wasn't available for Monaco.
Concerning the innovation part, we are coming to Monaco with a full-made carbon fiber boat. We shape our boat to optimize his aerodynamics, so we shape it in the form of a drop of water, and it allows to reduce the drag to air. And we added solar panels to our cockpit. We hadn't then last year. The solar panels that we choose are thin film technology, so they are very light, flexible solar panels, and they are very useful in the case of our cockpit because they can shape the cockpit and so optimize our energy consumption.
Okay, then, so finally, I will talk about eco-conception. So as you can say, you can know, sorry, carbon has no expiration date. So it's the third time that we use this cockpit, but not entirely. It's really some parts that we used. A majority of our boat is about the same cockpit as the last year. Many companies have to
throw away.
Yeah, sorry, to throw away some products, and that's why we have chosen to reuse these parts. For example, this year we have using scrap metal from the Ariane 5 rocket to reuse in our steering system, notably in the hydraulic cylinder. As a sorry, to add to this, we have a recovery of a clean hydraulic oil because a garage wants to throw away this oil, and it was clean, so we want to use it for our own system. Also, we can say that there is entirely no plastic in our boats. We have only a PLA, which is recycled plastic. And finally, we have to create our cockpit. We used carbon, and to use it, we used rolls of carbon with defects to give the carbons which been thrown away by the companies. So thank you for your attention.
Thank you. Do we have some question? Do you remember? I do have one question that might be important for the safety of the team. Could you please share what happened on your boat in between the connection, in between the carbon fibers and the electricity conduction after your battery fixation?
Oh, we have used the la mousse.
Foam.
Foam.
Yeah.
Okay, we have used foam between the battery and the carbon to have no conductive elements and to be safety about it.
Yeah, I know, but my question was before. Yeah.
What happened is that carbon fiber are conductor, so we unfortunately encounter a problem with our battery because we well, the battery turned off because the carbon fiber which was directly connected to the battery make it.
So you had current conduction in between the battery shaft and the carbon fiber of the cockpit. I guess that's something very important for all of you. Be sure that as soon as you will design a carbon fiber boat, that you will have conduction of electricity in between those carbon fibers. Especially for the boats that we are doing here, it's okay, but as soon as you have plenty of electronics, especially the electromagnetics area, you will have plenty of issue out of that. So as soon as you will have electricity in your future boat design, really consider to have some, let's say, fiberglass or some isolation in order to protect those solutions from at least CEM or any other thing. Other question? Yeah.
Thank you for the talk. Is there any benefit to having the solar panels be curved and wrapping around the carbon fiber? Or does that actually limit the amount of sun that reaches the panels?
Can you repeat, please?
You've made the solar panels curved.
Yes.
Is that good for the amount of sunlight that can reach the panel? Do you find there's a decrease, or does it not matter?
It was shows to improve aerodynamics more than to improve the light that the solar panel will have.
The solar panels are very in the same form of our cockpits, and with the reflect of the light, we have a lot of the reflect of the light in the water. We have a lot of light inside the solar panels.
Great, thank you.
Thank you. Jury, do we have a question? Thank you so much. So now, could we please have on stage one of the winners of the Tech Talks in the previous year? It's just to put you a bit of pressure. SolarBot 20, please come on stage.
So, hello everyone. I wanted to start off with showing you something quite crazy. This is our boat foiling donuts on the Twente Canal, which is something we have never achieved before. So, how is this even remotely relevant for the maritime sector? Well, we think its biggest market potential lies within medium-distance transport, like ferries, for example. And there have been some experiments with hydrofoiling ferries, but we think our electronic control system can really stabilize those boats independent of external factors. So, how do we do it? We have 3 sonars to measure the distance to the water, and an inertial measurement unit determines the orientation of our boat. Then, all of this information is sent to our BrainPi, which in turn controls all of our 3 wings separately to stabilize our boat and keep it balanced under any condition. And of course, that isn't all we have been doing this year. We have also designed some new propeller blades and even a nozzle to test their efficiencies at different speeds. And we have made new solar panels and added them to carbon backings to make them more modular and more future-proof. So, now that you know what we do, let me introduce you to our team. We are SolarBot Twente, a team of 21 motivated, multidisciplinary students who all took a year off studying to work on this amazing project. And right now, you are listening to my very last presentation about our boat. Because after the summer break, I will just be starting my master's and go back to studying. So let me take you on a journey of what my year looked like. I added a lot of pictures, so it might be a bit slow. Well, in September, we all started with reading a lot of documentation and getting inspired by the past teams. We are the 6th team right now. Then we moved on to the conceptualization phase, which was a lot of running simulations and choosing the best materials for our designs. Then, after the Christmas break, it was time for our production phase. And let me tell you, there is no better feeling than finally holding your very first self-designed piece. That is, up until you also get your second piece and they just don't fit together as well as you designed them to. So, after a lot of creative solutions, and once the weather gets better, we get our boat into the water for some testing. And we mainly test at the quite calm Twente Canal, but we also took our boat onto some rougher waters to do testing on wind and waves. And then, finally, it is time for our racing season, which has been quite successful so far with a win in Enkhuizen. So, that brings us here in Monaco. This is what we have been working towards as a team this year. It's the cherry on top of an amazing year. And while it feels great to be here together, it also is kind of weird to say that this is the last thing we will do together as a team. But it's good to know that there's a new team waiting in Enschede to start their journey next September. So, thank you for listening.
Congratulations. Do we have some question? I guess they won the last race, so you should have plenty of questions.
Hi. Congratulations for your good performance. I would just like to ask you, where do you place the 3 sonar measurements? So,
yeah, we have one placed at the front of the boat. Let me see if I can show you. So 1 at the front of the boat and 2 at the sides. So, yeah, I'm too short for that. So we can try to see if we wanted to try and see if we could also do some prediction of the waves with these sonars, but now they're just really really useful for measuring also the roll of the boat, because we have them on the sides and one on the front for the
Okay,
height.
so for the roll, you use the differential between the two sonars, or are you using also the...
We are using mostly the inertial measurement unit for that, because it's just really, really accurate.
Okay, thank you.
Sorry, another question? Maybe start first and jury after.
Hello. So I wanted to ask you, it seemed like the propeller blades are mounted into the hub or something from the photo. Could you explain on that?
Well, we have a contra-rotating propeller, which, we have... I see my propulsion engineer just nodding at me. The contra-rotating propeller works with two axes, which both turn different ways, and they move through each other. So that makes them able to move separate ways. And we can just attach those different propeller blades onto those axes, and we can swap them around. Does that answer your question?
Yeah, I wanted to know why you choose to manufacture the blades separately from the hub and not all together as a whole.
Yeah, I think that's just because it was way easier to produce. This works, and we 3D printed them, so this was the easiest way to do that.
Okay, and another question, sorry for the... in which material did you decide to produce the blades?
I think this year they're aluminum, right? Yes, I see some nodding.
Okay, thank you.
Just a quick one. You also have ones on your board. Is that just a picture, or the ones are collaborating with the sensors?
Sorry?
So you have ones like moth.
Oh,
you call them floaters.
Yeah. We that was our old system. We used to measure the distance to the water with those. We call them flotters on both sides of the boat, but with these sonars we don't use them anymore, and the sonars are way faster and way more reliable, so yeah.
Okay, so it was just to tune up the electronic system.
Yeah.
Other question? I do have one. In fact, could you please give us some idea about the life cycle assessment?
Well, we use carbon fiber for the hull of our boat, which isn't the best material to use and to recycle, of course. But we have been using this hull for 4 years now, if I'm correct. So we try to reuse a lot of our materials. And for the production of other materials, we try to do mostly additive manufacturing to keep the production, I don't know the word, to keep it all low and to have it as sustainable as possible. And a lot of our partners are located very close by to our office. So we also try to save a bit on the shipping costs of carbon emissions. So that's some things we do, some small things.
Thank you. And if you, I understood that you also produce your own electronics, is it correct?
Yeah, we try to do most of them by ourselves with help of some partners.
And would you be okay to share that with your other team as an open source?
To share like the
sensors, the controls of the flight in order to help the other team to be able to achieve a stable flight?
Yeah, I think we would.
Yes, thank you. That was, I guess, the most important question. And thank you so much. So can we please now on stage, sorry, it's written very small, HVA Salmon on stage. It's okay? Is the remote?
It's in stage. So forward, come back.
Well, hello everybody. Thanks for having us here.
Safety issue.
Wait.
Could you please ask?
Shall I try again, if it works? Or?
So then we can play a game. Huh? Who made the biggest mistake today?
I think it was me coming up stage.
Good answer. Well, I guess you made a good one. Huh? I did not ask the question earlier, but...
Yeah. Apparently we're good to go. So after this, I'll try and do my best. Let's see. So we, as well, are a team from the Netherlands. Of course, we're known for our flat little country with lots of rain and clouds, so solar class might be interesting. About our school, we're apart from the HVA, it's the University of Applied Sciences in Amsterdam. And as part of the HVA, we have a section Clean Mobility, which consists out of 4 vehicles that are trying to be as environmentally friendly as we can. So that's why the solar class is a thing as well. With Clean Mobility and the solar boat Salmon, we have a team of 9 as well as electrical and mechanical engineers, second-year students that partake in this project as well. It's going on for 1 year as well as the previous Dutch team. However, we do that as a part of the study, so we do that for the ECTs as well. So our team, here we have a picture of it, is consists of us 9. Today we are here with 7 only. Some are still in the Netherlands and will be joining us on our sail back to Amsterdam. So that might be something you've heard already that we're planning on doing again. Which brings us to what we're doing. We're competing in as well the Eco Competition Prize and the Innovation Prize this year. And for the most part, our boat is designed for long distances. So one of our main goals is we have now a boat that can reach as well on the sail back to Amsterdam. We're trying to maintain 100 kilometers a day. So we can provide some insight for companies, for example, that deliver groceries in towns and everything, that they can do it on 1 battery charge with X amount of solar panels. So that's our goal, to help in that regard. So our inspirations, we have, well, this is our hull that we've been using for several years now. And we're trying to get the boat on hydrofoils as well. We're experimenting with 2 types. One, we have the J type that's shown on the picture. That's a static one right now. We're still, trying to make it work as best as possible. However, we're also trying to make do with the T type of foil. We're actually contemplating if we can make those T-foils adjustable. Hopefully it will be coming next year. What we also have is we have a fairly long boat design because we were not made for the speed and maneuverability, but more for the durability or the long distance type of routes. Then the hull shape and as well as the foils, they're also, as previously mentioned, more of a sharp edged design, and some of them are indeed inspired by previously mentioned somewhat teardrop form. And then this year we have experimented with some prop designs as well to make them more efficient. We are actually printing our propellers in-house, carbon printing, I believe. And this year, actually with the test we've done, we've ran it today on our new propellers as well. They're not the fastest yet, but they do have a bit of efficiency, more of efficiency than the previous ones. However, we are trying to still up them a bit more so we can get up to a higher speed for the foils that we're wanting to fly on. Let's see what the next slide brings us. Well, as mentioned, we had built Clean Mobility several vehicles, so that was why our budget was a bit difficult to explain, because it is divided within Clean Mobility for those 4 vehicles. So pardon us for that. We do have some things that we have put more of the focus on this year. Where we use a new motor driver. It's a three-phase motor driver, and we, as mentioned, trying to make more efficient propellers. We also have a new 7-to-1, 1-to-7 ratio gearbox. It's a reduction, because otherwise the prop would spin a little too much, or too much RPM for the gearing we have, which would not work in this case with our motor driver. Then we have some things how it's built up. So we have the 9 engineers, and we divided everything in some subcategories, so as the hydrofoils, as the propeller system, and we are willing to do the counter-rotating propellers as well. So those are a couple of our systems that we have, and that's within the boat where we have our costs and how that has been divided. And also we have some people working on the imperfections we had lost in previous years. So those are the main things. Then we have some additional info as well. So we're using mostly with Fusion and Inventor, with the CAD drawings, of course, as mentioned, we do the 3D printing as well, and we try and milling our CNC parts in-house as well. We work a lot with glass and carbon fibers, and this year we also, as shown on the picture, made a new stern piece that needed to be reinforced because we broken some during the year. Let's see. Then, so the main goal is, because our boat is very long and a bit heavy, to reduce as much of the kilograms we have. We are now around 120 kilograms, and we are wanting to push and get that down as far as we possibly could. So that's why we're trying to use the carbon, the glass, and the fibers and the aluminum instead of some heavier materials. Let's see. And then we had faced some problems during the year. Of course, we had some problems with delays and time, but also with the counter-rotating propellers that we're working on that has not really been very successful. We're still trying to get a perfectly designed to make it work. And as mentioned, we broken multiple rudders during testing, especially when either trying to get on hydrofoils, or if there are any some, how would we say this, if the steering forces on the rudder will get too big, then we had some problems of it breaking and snapping in half. And so that's some of the things that we're hopefully... it's time, I've heard. So in that case, then, if there are any questions... Oh, it goes back. Please.
Thank you. We can upload. Do we have some question? Do you remember?
Yes.
Is your foil concept improve drag, lift, or both?
Sorry, could you repeat that one more time?
Your foil conception.
Yes.
Is improve lift, drag, or both?
So what we're now having with the static ones, the static foil, it's generating a lot of lift. However, because it's a very aggressive angle of attack, after we get on the foils, it tends to create more drag than we could take. So then we do not have the same efficiency as we would have with a foil that, for example, could be the T-foil that we can pitch, so we could change the angle. So we're now generating a bit too much of drag with the foils, if that answers your question.
Yes, that's something a bit important also to share with all of you. As soon as you will try to design a foiling boat, the width is a friend. In fact, the wider will be your boat, the more stable, so the easiest it will be to be able to take the movement of the boat. So I was a bit surprised when I see your boat, so I asked the team if you were limited into the width of the design in the solar class, because I don't know the rules as much as the other. But,
it's not necessarily the limitation of width or as the length. However, it is not made for this competition. So it's made purely and almost only for efficiency. And we're trying to make this hull work as good as we possibly can for this competition, because we're more of a long endurance type of hull shape. So hopefully that might give some insight in why the hull is designed this particular way.
Yeah. And I also invite you to have a look to a Netherlands team named, I forgot his name, the design, it's named Hulvane. So it's Netherlands patent. I invite you to have a look at that. If you design an Archimedean boat, let's say a boat which is floating, try to optimize the flow of the stern of the boat. That's something where you can easily achieve in between 5 to 8% drag reduction on the hull. That's something that I did not see yet on this competition, but I really would love to see such a design.
Okay. We'll
Thank you so much.
Yeah, thank you.
Can we please have on stage Nerier de UTT Marine? UTT, pardon, on va parler français. Il donne les micros.
Hello to everyone. We are the team Nereid. So we come from the University of Technology of Troyes. This is our first participation in the energy class. We were a total of 19 members participating in the project, with 9 people in the first semester and 13 people in the second semester. So we have people from different specialties, mechanics, materials, and telecommunication, which makes a team that is pretty whole and helps with a lot of different types of situation. So today we are competing for the Eco-Conception Prize because we chose to face the environmental crisis with an environmentally friendly boat. We chose the materials that are eco-friendly, for example, wood, reusable plastic, aluminum. Our whole structure is made out of aluminum. I'll get to that a little bit later. And we tried also to use clean energy. In the beginning, we were supposed to use hydrogen and a battery. Unfortunately, we had some problems with hydrogen lately. So we will only be running on batteries for this competition. And we have an electric engine.
So now I will talk a little bit about the project itself, a little bit more in details. So we had 3 main points of work during the year. The first one is the design of the boat, because it is the first participation, so we had to do almost everything. We started from 0, so we had to find the optimal dimension, reduce the cost, find the perfect weight, etc. We also worked a lot on the energy part, because we wanted to do an hybrid system between hydrogen and battery. I will give you more details after. And finally, a major part was also the propulsion system. So to give you an idea, the project cost, it has an overall budget of almost 17,000 euros. And then you have to add to that the 4,000 euros which correspond to the transport to come here. About the timeline, so Maël told you that it is the first participation ever of our school. So we started in September by the conception of the boat and all the systems until December. Then we started to buy some components, and from March to April we started the production of the cockpit and also some fuel cell tests into the laboratory of the university. And then, since May, we received the engine, the battery, and we did the first trials on water. So about the propulsion and the energy on board, I told you that we wanted to do an hybrid system, which was conceived with a battery of a capacity of around 5 kWh and also a tank of hydrogen of 5 liters. And all this system is here to power the motor that you can see, which is an 11 kWh motor. So after that, we wanted to have something very efficient, I think just like you. And we had 3 points of optimization. The first point was the weight. So we decided to put the center of gravity at the end of the boat. We also had the propulsion. And as I told you, we have a very good motor because the efficiency is around 90%. And finally, we did a very big work on the energy management because we wanted to do something smart to find the perfect balance between electricity and hydrogen on the boat.
Another big part of our project was some simulations for the kind of weakest part of our boat. The thing that could break the most easily is the motor support. We did some simulations on ANSYS and Abacus. Here we can see the results. This is the design, the optimal design that we found with aluminum tubes and just a wooden support in the middle. So for our life cycle assessment, we have 9.5 tons of CO2 emitted in the total of the project. The most harmful is the transport towards Monaco. We came here with 3 cars and a trailer. And the most polluting elements of the boat would be the batteries, the motor, and then the aluminum. So for the eco design, we opted for the simplest structure possible. Provide aluminum tubes that use 70% recycled aluminum, and aluminum is recyclable indefinitely. And we also tried to give a second life to some seats, and we reused some materials to construct some small parts of the boat. And finally, we just want to say that we are very happy to be here after 4 nerve-wracking days with some problems that we did not expect. We probably just passed about an hour ago our technical inspection, and with a lot of hard work from the team and a very responsive team to every problem, we are now able to compete tomorrow.
Congratulations. Do we have some question? I guess it's a bit late, huh? Yeah.
So the question is again about the propeller, since it's so unconventional. First of all, is the 90% efficiency, is it of the whole powertrain subsystem, or is it only of the electric motor? And then you have to multiply with the efficiency of the shaft and the propeller itself.
So the efficiency is not the whole energy system, because in the initial part we had hydrogen, which is not the most efficient part of the energy. The efficiency is only from the motor itself, without the batteries.
Okay, but counting the propeller and the shaft, right?
Yes, that's counting the propeller and the shaft. So basically what it does is having a rim profiled structure. It helps, once it is launched, it helps to keep this dynamism that is going.
Okay, and also I wanted to know how much in terms of percentage does that propeller design help? Like, what's the improvement?
I am not exactly sure of the exact calculations for this motor. I have seen that for some other motors, they had about 30% less energy consumption-wise than regular motors.
Yes. French style, huh? Do we have another question? Jury? I guess due to out of time. It's okay. Thank you, gentlemen. So I know it's late, so please give a big applause to the next one. We still have 2 teams to join. So could you please have on stage AECB team? You put a lot of energy, huh? Yeah.
Good evening, everyone. It's nice being here again. My name is Vinko, I'm the team manager, and this is Martin, our chief of electronics. We are Association of Applied Technical Sciences. We are a student association, and we bring together students from 6 different faculties from University of Rijeka. For those who don't know where Rijeka is, it's a 3rd largest city in Croatia, located on the north of the Adriatic Sea. Our association has many projects, including electronic bike, autonomous vessel, solar boat. But this year is the first time that we are presenting our class boat, energy class boat.
This is our boat, Malavitra. It's a monocoque design powered by a lithium pyrophosphate e-propulsion battery with 8.9 kilowatt-hour battery, and it's located in the back along with all the electronics. We are using e-propulsion engine with 6 kilowatt power. We custom-made the propeller, so it's a 3-fin high-pitch propeller made out of carbon fiber. Next slide. This is our electronics, so it's made from 4 modules from Victron Electronics. So we have a BMS that controls the charging and discharging of the battery and overall condition of the battery. The MPPT, which collects the solar panel, the energy that comes from the solar panels, and through the BMS charges back the battery. We have a DC-DC converter used for powering up our relays, fans, and also the telemetry system. The telemetry system is connected to a GSM card, which to the cellular network we can onshore get all the telemetry information, and also a GPS antenna, so we can know where our boat is at all times.
So for the production, we had a lot of problems manufacturing the whole of the cockpit. First, we used the carbon fiber 245 grams per square meter in 2 layers, and Soric core made of polyester, and we thought it would be excellent, but we had problem with the manufacture of the mold. So the mold wasn't completely made to the end, so we had to improvise. The main problem was the air leaking inside. So when we got our hole outside, it was pretty porous, filled with air. So when we tested it, when the pilot entered it, it cracked. So we reinforced it with more 3 fibers. So the cockpit is a bit overweight, but we are satisfied now because it's pretty hard and robust. Here is the time-lapse video of producing vacuum infusion for the hull. The 3D design and the calculation was made in the MaxSurf program, the 3D modeling was made in the SolidWorks, and the 3D visualization was made by the company called Via Cornell, and thank them for that. For our marine shift, when we use the LCA tool, I actually figured it out that it's reported that we got a lot of waste, which is basically true, but not true because we like to recycle things because of the three main reasons. It's cheap, we do something good for the environment, and we get the materials pretty fast. We used, in 2021, we had, it was our first time here with the solar class, and the boat Delta One was made out of the polyester, was made by the fiberglass, actually fiberglass. And so we thought it would be good for making reinforcements for our energy boat. We used it to make the bulkheads, reinforcements, and even distribution box. We also cut the motor holder to reinforce the motor mount for this year's boat. Questions?
Congratulations for you and for all the ones which stay, because I know it's a bit long, so thank you for that. Do we have some question on the stage? Yes, one.
The design of your cockpit seems like it's more closer to a hull from a boat and is really different from the design of other teams. What was the main idea behind it?
Well, it was pretty easy to produce it because then we had only one compartment, and it looks fast. It looks pretty nice, you know. We love the way it looks. I hope that I answered your question.
It is wonderful, but is it good like for aerodynamism or?
We thought that, and we will see. Actually, it acted very good today. It caught 12 knots. I think that our main idea was to go with 2 motors, 2 e-propulsion motors, but it was a lot heavy. So probably next year, if we compete in the energy class, we will make some modifications or make 2 compartments, you know, like every other team does, with the battery on the back and the cockpit small for the driver.
Okay, thank you.
Thank you. Design is also very important in the yachting industry. Do we have other question? I guess it's clear. Thank you so much.
Thank you.
Thank you.
Can we please have MEB on stage? The last one of today. Thank you for waiting.
It's already. It's like this already.
So, hi, I'm Vittorio Geraci, one of the designer of Messina Energy Boat. So, our team is composed by 13 members from different courses of our university. So, we competing for the energy class, for the eco-conception prize, and for the innovation prize. So, we started to work like 7 months ago. From a blank sheet, we start to draw some lines of an aluminum structure. We have an 66 alloy structure that is quite strong. We inspired that by the Formula sidecar, that it's a racing car, a class car in Italy. So after that, we covered all of that with recycled sails. So our impact is quite low. For the mechanical system, also we use scratch from our laboratory. So also for that, we haven't bought a lot of components. So for the life cycle assessment, as you can see, we don't have so much critical CO2 emission. The only critical CO2 emission came from the propulsion production. So we cared also about the transportation method to come here, because it's one of the part of using the product and use the boat. For the innovation prize, we have a few innovations. So we used a new type of manufacturing with additive manufacturing of basalt plus PETG to do the mechanical connection to the cockpit. So we want to improve that technology and use that to build other components for our boat, maybe in the next years. After that, we take inspiration from sailing equipment for the steering system of the boat. So we have like a Denima cord that steer the boat. As I said before, we take the inspiration from the Formula sidecar. It's a really strong structure, is an alloy structure, and is quite light, so you can even lift all the cockpit without anything, obviously, with a finger. So it's a really, really low weight cockpit. After that, I can say to you that we used the numerical system to try to design the boat. So we learn in 7 months how to use the Siemens suite, the ANSYS suite, and everything is okay, and everything works properly. Last but not least, there is a lot of number. I don't want to bore you with all the data of the boat, but as you can see, we have the production and budget. That it's quite low. We didn't expect that it's that low. And we have the data about the energy on board. We have a 9.5 kilowatt lithium battery and a 15 kilowatt electric propulsion system. Finally, the propeller. In this case, we see one of our 2 propellers. We have 2 propellers that we can choose in base of the competition that we are in base of the race. So in this case, you can see the 4-blade propeller, and there is the data. So if you have any question, I can answer them.
Thank you. Do we have some question?
You mentioned that you had 2 propellers. What's the difference between them?
Yeah, so one of the propeller is a 4-blade propeller. That is the one that you see in this photo. That is that data. And the other one is a 3-blade propeller. So we choose this type of propeller because one is for the endurance race, that it's most efficient, and the other one is a more accelerating propeller. So it's the best to use in acceleration race when we need power to go fast.
Thank you.
You're welcome.
Other question?
You said you have a homemade motor. homemade engine. What
no.
exactly do you do?
No. So
inside?
maybe there was a little bit of a misunderstanding, because the motor, we bought the motor from, I don't know if there is some good photo here of the propeller. Maybe the west one is there. Okay. So we bought this propeller. It's our first year there. So we didn't have enough time to think about to do a propeller, to do a motor. So we bought that, and the construction case, the manufacturer, so give us a lot of help to improve it, to make it work better.
Other question? I do have one on your idea. What will be the, let's say, the best optimization that you can apply on your boat following the first days of test?
So, okay, in these days we had a lot of work. So we had to change a lot of things for the regulation to make it work better. But I think that in our case, we are maybe the most ecological boat, because we recycled everything on board. So maybe it's our strong point.
Thank you for that. And could you also please share to the other team, because I'm not sure they know that, where is your throttle? How do you manage the gas of your boat?
You can repeat the...
How do you manage the gas of your boat, the acceleration?
Okay, the acceleration is a new type of method. I have to search, maybe in this render you can see it. We have a pedal, it's like a car. So the driver doesn't need to leave the hand from the steering gear. So he can hold the two hands on the wheel and accelerate with the foot. So it's the best thing to do in a slalom race, because you have to steer really fast and you can leave your hand from the wheel.
Thank you so much. Sorry, we have another one. Excuse me.
I was wondering about the pedal you just mentioned. How does it behave in the waves? Because here in Monaco there's a lot of waves, and I was wondering, is it a problem to steer your boat with the waves and the pedal?
Okay, so it's all in the hand of our pilot. So we didn't have enough time to think how to have a best solution, because not a best solution, how to improve that thing. But our pilot learned a lot in the Strait of Messina, because in the Strait of Messina you have a lot of current and a lot of change of current. So maybe he could manage that situation.
Thank you. I guess that's all for tonight. Thank you so much.
Thank you.